So now we want to think about what happens in a market when there actually is a network effect. So remember that previously we thought about markets without network effects, where people just had reservation prices describing how much they value the product. Now we want to put that network effect into the model. So to motivate this, let's be concrete about an example. Let's think about Facebook. For most people, or at least anyone who's interested in using Facebook, Facebook is more valuable if more of the people that they know actually use Facebook. And that's true generally for social networking sites and for lots of other products, particularly technology and software. So I need to somehow get into our model of what happens in the market, the idea that what a person is willing to pay or the cost they're willing to bear to use a product or a service actually depends on how many other people they think are going to use this product or service. So let's add that into our model now. Let's suppose that Z is the fraction of the population that's actually using our product or service. I want each person's reservation price to depend on Z, as well as, of course, on who they are, because people have different reservation prices. And we're going to model this very simply. We're simply going to say that now person X's reservation price is his old reservation price R of X times some function f of Z, where f is an increasing function. F is meant to convey the idea that your reservation price gets shifted up or down based on how many other people are using the product. So I want f to be increasing so that your reservation price, the actual one, will be higher if you think more people are going to use the product. Now this has made the market a lot more complicated because now I don't know anyone's actual reservation price until I know the fraction Z of the population that they expect to use the product. So in order to figure out what goes on the market, we're going to have to put together individuals' reservation prices with their expectation of who's going to use the product, and then we want their expectations to be correct. Okay, let's build this up piece by piece, first by thinking through some fairly simple examples of how this might work. So let's start with an example in which we say that person X's reservation price, ignoring for the moment the network effect, is just 1 minus X. So person 0 has a reservation price without network effect of 1. Person 1, of course, has a reservation price of 0. But I want their reservation prices actually to also depend on what fraction of the population is using the product. So let's suppose that function f of Z is 4 times Z. So for example, if people guess that everyone's going to use the product, then that just multiplies everybody's reservation price by 4. 4 times equals 1, of course, is 4. That means that person 0, the person with the highest actual reservation price, now has a reservation price of 4. Person 1, of course, still has a reservation price of 0. That person's not going to use this product no matter how many other people are using it. That would now then give me the actual reservation prices that we can see in this blue line on our curve. But remember, that's the reservation prices if everybody thinks that everyone's going to use the product. The question is, are they right? How many people are actually going to use the product when everyone expects everyone else to actually use it? Well, that's going to depend on the price. So let's pick a price in the market and see if their guess is correct. Suppose, for example, that the price in the market is actually a half. Let's find out who's going to use the product. We know how to do that. We simply take a half over to that reservation price curve, and we find the value of Z where the person at that point is just willing to pay a half for the product. Okay? It doesn't really matter so much what that value is. The key is to notice that not everybody is going to use this product because everybody to the left of that point Z less than 1 uses the product, of course, but everybody to the right does not. Those people out there to the right of the point marked Z less than 1 aren't going to use the product, even if they thought, of course incorrectly, that everyone would use the product. That means that a guess of Z equal to 1 is a bad guess. In fact, as you can quickly see from that graph, no matter what the price is, if it's anything bigger than 0, there's no way that everybody's going to use the product. That can't be an equilibrium. Now we could try other guesses and see if we can do better. Suppose instead we guess Z equal to half. That is, now suppose everyone guesses that only half the population is going to use the product and the other half is not. Now, at this point, we have to think a little bit harder because we have to figure out which half are we talking about using the product. Well, that's actually not all that hard. It's going to be the people whose names X are closest to 0 because they're the people who always value the product highest. So this guess of Z equal to a half would be a guess that everyone whose name is less than a half uses the product, and everyone whose name is greater than a half does not use the product. Okay, let's put that into our graph, see what it does the reservation prices, and then check to see if it's right. Well, what it does now, remember f of Z is 4 times Z, is it takes everybody's reservation price, which is 1 minus X for person X, and it multiplies it by 2, 4 times a half. That's the blue line in this next graph. We can ask now if those are the reservation prices that we have with the guess of half the population using the product and with the price still equal to a half, will in fact half the population use the product. Okay? So we take that price of a half over to our reservation price curve and we check, does it hit at half the population? And as you can see in this graph, no, it hits at some value Z that's bigger than a half. So the guess of 1/2 was too pessimistic, right? At a price of a half, if everybody guessed that half the people would use it, in fact, more than half the people want to use it. Whereas the guess of everyone using it was too optimistic. Okay? Well, this is beginning to give us some idea of what a possible candidate for a good guess is. We could imagine picking a different guess. Suppose we all guess that 3/4 of the people are going to use the product, and we can run through exactly the same exercise. If we do that, the reservation price curve is going to be 1 minus X multiplied by 3, 4 times 3/4. We can take that blue curve now, which has been shifted to have an intercept on the vertical axis of 3 and still an intercept on the horizontal axis of 1, compare it to the price of a half and see what the right fraction is. Now here you can't quite see from the picture without doing a little math, but in fact the fraction who's going to use the product, if everyone thinks that 3/4 of people will use it, is actually 5/6. So 3/4 was too pessimistic. In fact, more than that are going to use it. We could imagine continuing to do this over and over and try to get a guess that works, but that's a painful process to go through, and it's actually not a good way to do this. What we really want to do is come up with a technique that will let us find all of the possible correct guesses. That is, all the possible expectations people could have about who's going to use the product that will in fact be correct. And that's what we'll look at next.